Welcome back to The Explainer. Today, we're tackling a real titan of the programming world, one of the most durable and, popular languages ever, Java.
You've probably heard this phrase before, right? For decades, this has been Java's famous promise to developers. And honestly, this simple, powerful idea is what made it an absolute global phenomenon.
What does that really mean? Run anywhere. And how did this one single idea completely change the game for programming forever? All right, let's get into it. Let's see what makes Java tick.
So, what's the secret sauce here? Well, the magic behind write once, run anywhere actually isn't magic at all. It comes down to this really clever three-step process that guarantees your code is genuinely portable.
Okay, so here's how it works. Step 1, you write your Java code. Pretty standard stuff, right? But then, step 2 is where things get interesting. A special compiler takes your code, but instead of turning it into machine code for, say, a Windows PC or a Mac, it creates something called bytecode. Think of bytecode as a kind of universal dialect. It's an intermediate language that isn't tied to any specific computer or operating system. It's written for a theoretical Java computer, and the genius of this is that any real computer can be taught to understand this one universal language. So how do they learn it? Well, you need a translator, right? And that's where the Java Virtual Machine, or JVM, comes in. It's this piece of software that you install on a device, and its one and only job is to act as that universal translator. It takes the bytecode and converts it into the specific, native instructions that your particular machine can actually understand and execute. And what's the result of all this? Platform independence. That's the holy grail right there. You write your code just once, and as long as the device has a JVM installed, it can run it, period. No need to rewrite your code for Windows, then again for Mac, then again for Linux. It just works. That's the promise delivered. Okay, so that portability is huge for sure. But that's just the beginning of the story. Java was designed from day one with some seriously heavy-duty tools for building big, complex, and super reliable applications. So let's pop the hood and see what kind of engine is running this thing. At its very heart, Java is what we call object-oriented. So what on earth does that mean? Well, think of it like this. A class is like the blueprint for a house. It defines all the properties, how many rooms, doors, windows. Then an object is the actual house you build using that blueprint. This simple but powerful idea is what lets developers build massive applications that are neatly organized, easy to reuse, and don't just collapse into a messy, tangled web of code. Now, when it comes to performance, Java hits this really interesting sweet spot. It's way, way faster than older languages that had to interpret code line by line. So how does it do that? It's through a clever trick called just-in-time, or JIT, compilation. See, as your program is running, the JIT compiler is smart enough to identify the pieces of code you use the most, and it optimizes them on the fly, making them run super fast. So you get this amazing balance, the flexibility of an interpreted language, with speeds that get really, really close to a fully compiled one.
And this is where we see its power for the really big jobs. Java has built-in support for something called multi-threading. The easiest way to think about this is like having a whole crew of workers on a single construction project. Instead of one person doing everything, you have different people doing different tasks all at the same time. This ability to juggle multiple things at once is what makes apps feel so zippy and responsive, and it's absolutely key to Java's ability to scale up.
Another feature that makes Java so incredibly robust is how it handles its own memory. In a lot of other languages, the developer has to manually keep track of memory, which, trust me, is a huge source of bugs and crashes. But not in Java. The JVM has this amazing thing called a garbage collector. It automatically sweeps through the memory, finds any objects the program isn't using anymore, and just clears them out. It's literally like having a self-cleaning kitchen. It's fantastic.
Okay, so Java's been around for decades now, but it's still at the top of its game. That's no accident. The reason it's still so dominant is because it has never stopped evolving, and it's built this incredible ecosystem around itself.
Take modern Java, for example. Since version 8, it's really embraced features from a style called functional programming. The core idea is to treat actions as little pieces of data that you can just pass around. This leads to code that is incredibly clean and concise. I mean, look at this. This is a lambda expression. It can take what used to be a long, complicated loop and shrink it down into just a single, elegant line of code. It's a huge deal for readability.
And on top of that, developers almost never have to start from scratch. Why? Because Java comes with this gigantic pre-built library of tools called the Java API. You don't have to reinvent the wheel every time. Need to connect to a database?
or handle files, or build a secure network connection, odds are there's already a powerful, rock-solid, pre-tested tool just waiting for you in the library. It saves an unbelievable amount of time.
But what if you do get stuck? What if you run into a problem that's not in the library? Well, you are definitely not alone. Java has one of the largest, most active, and most helpful developer communities on the entire planet. We're talking millions of people writing tutorials, building amazing open source projects, and answering questions 24/7. They're ready to help solve pretty much any problem you can dream up.
All right, so we've seen the promise of run anywhere, and we've looked at the powerful tools under the hood. Now let's zoom out a bit. Where does all this incredible technology actually show up in your day-to-day life?
So where is it? Honestly, the short answer is pretty much everywhere. It's the silent workhorse powering countless web servers and the huge enterprise applications that run big corporations. And oh yeah, if you're using an Android phone, you're literally holding a Java-powered device right in the palm of your hand.
And it's this incredible flexibility that explains exactly why Java is still the backbone of so much of our digital world. It just plays so well with other technologies. It can connect seamlessly to databases and basically act as the industrial-strength glue for building these massive, interconnected systems that absolutely demand both power and rock-solid reliability.
And that brings us to a final, really fascinating question. Here we have a language that was built from day one with this mission, to run anywhere. It's already shaped the web and conquered the world of mobile. So now, in a world of cloud computing and countless smart devices, where is Write Once, Run Anywhere going to take us next? You know, its founding promise might just be more relevant today than it has ever been.